Okay, so we're starting week 3 in geometry, and one of the things that we're going to do this week is we're going to go over the chapter review, chapter 2 review. Then we're going to talk a bit about the project and what you decided to do that. There's a prerequisite quiz that I'm going to send to you. All right, you're supposed to be taking care of that. I didn't get any emails from last week about the prerequisite quiz. Was there any questions on any of those problems? They were pretty straightforward. Okay, the goal that you have for this class is to continue to develop a folder that has all those prerequisite problems completed. All right, it is the start of the college algebra class that you're going to take after the first of the year. All right, and so those things, I think the first 78 pages or something like that, is all things that you're supposed to have covered in other math classes. And so this is a chance for you to go back over and either remember it or say, oh my goodness, I've never seen that one before. Right? And so you're going to have those together. And after you've done that, you're going to take a quiz, which is also in that book. And you should be able to pass that quiz because you have remembered and still can do all of those things from, in some cases, 3 years ago. And so what we found a couple of years ago is that some of that information it had been so long since some of the students did it that they had forgotten what the skill was. All right, and so this is a way to be able to put those two things together. So this prerequisite from the algebra, for college algebra book is important for you. It's the start, it's the foundation for the class you're going to take after Christmas. Okay? All right, so we're going to move on to that. And what I'm going to do because of the video is there's a chapter 2 quiz that you're going to take, a little 5-question quiz, and we're going to take it after we've done the review. Okay? All right, so let me now see if I can get to this section. All right, so if you want to take some notes, if you work through the book like you were supposed to, this is problem number 37. All right, now it says, suppose L and M are parallel lines and T crosses L and M in a figure like this. Okay, now, what is line T called? Vocabulary word. Transversal. Transversal. Okay, you've got to remember that word, that vocabulary word. And then L and M are called parallel lines. If you had to tell me that L and M were parallel, what is the math notation that explains that fact? You would say L, and it's usually lines are written in cursive, L is parallel with M. That's what you would write to be able to do this. So instead of this, they could have had this notation sitting right there and done the same thing. And on testing, that's usually what you see. You see this notation instead of these words. Okay, now, I also then, last week I told you what does perpendicular look like. How does this change if the lines are perpendicular? All right, it's an upside down T. So L is perpendicular with M, looks like that. And in that case, I could also do that by putting a box in there. It would also show the same thing. Okay, thank you, Lord. Nobody got hurt. Okay? So those are parts that we're trying to be able to pull together. So, now, why is angle 3 equal to angle 1? All right, this is a vocabulary word. Starts with a C.
Corresponding angles.
Corresponding angles. Okay? Now, all right, what are one of the other words that are in the congruent part besides corresponding? Starts with a, there's another one that starts with an A.
Adjacent.
All right, no, not adjacent. Adjacent are not equal. Alternating, right. Alternating what? Alternating, come on, class. Interior or alternating exterior. They are all congruent. Now, the adjacent angles are supplementary, so they're going to add to 180. But the corresponding angles are congruent, therefore we have an equal sign. All right? Now, angle 3 plus angle 2 equal 180. Yeah. Okay. Now, why does angle 1 and angle 2 equal 180?
Because
it's real easy.
the angle across from, I'm not using that vocabulary.
Substitute.
Because of substitution. We know that angle 3 plus angle 2 equals 180. Right? Why? Because they're adjacent angles. Right? And we know that angle 1 equals angle 3 because they are corresponding angles, and therefore angle 2 plus angle 1, did I do that right? Yes, well, I should do it this way. Angle 1 plus angle 2, because I substituted here, equals 180 by substitution, and therefore the same side, interior or exterior, are supplementary. Okay.
Again, so what is,
okay, all right,
could you go through the relationship
in,
between like 1 and 3?
Okay, 1 and 3 are corresponding, so they are equal.
Corresponding.
They're corresponding. We're going to do a little bit with that in a minute, because that's an important skill. So 1 and 3 are corresponding, right? We know that 2 plus 3 equals 180 because they're adjacent. So we can write an equation that says angle 2 plus angle 3 equals 180. Why? Because they're adjacent angles, and adjacent angles are supplementary.
They're adjacent.
Right now, we know that angle 1 equals angle 3 because they are corresponding.
Angle 1 equals angle 3 because they're corresponding.
Because they're corresponding.
And angle.
Right? And then, by substitution, we can say angle 2 plus angle 1 has to equal 180. And that means that the same side interior angles are supplementary. Okay? Now, that gets us to a place, I think, where I want to go through the vocabulary again. Okay, so, let's see. We have corresponding alternating and vertical. Now, I am going to leave off alternating interior, alternating exterior. I'm going to just call them alternating angles. And then on this side, we're going to have adjacent, and we're going to have same side. Same side interior, same side exterior. These are going to equal 180, and these are going to be congruent. Okay? Now, I've got to do else to be able to get us some room. Alright, so I'm going to put two parallel lines. I'm going to cut it with a transversal, and this is going to be 1, 2, 3, 4, 5, 6, 7, and 8. Okay, now I want to know a relationship between angle 7 and angle 1. Okay, by name, where they are vertical angles. Why? Because they are across the vertex from each other. Okay? Alright, so they're vertical angles. So that's vertical angles. Now, what happens if I ask you about angle 8 and angle 7?
Alternating.
They're not alternating because
They're corresponding.
Well, all right, now they're not because they're next to each other, so they're adjacent. They're adjacent because they're next to each other. See, now what's the difference between 1 and 7 and 8 and 7? 8 and 7 share the side as well as the vertex, whereas 1 and 7 only share the vertex. All right, so because they share this side, they're adjacent, and what do you know about adjacent angles? They add up to 180. Everybody say 180.
180.
Adjacent. Say adjacent.
Adjacent. 180.
So adjacent angle. Now, name a pair, Caitlin, name a pair of adjacent angles in this intersection.
5 and 6.
5 and 6. Name another pair.
4 and 3.
All right, Casey, name another pair.
3 and 6.
3 and 6. Did we get them all?
4 and 5.
4 and 5. Okay. All right. All right. So now, and those are what? Adjacent angles. And what do you know? What mathematical equation can you write? Angle 3 plus
Angle 6.
equals 180. Okay. So we have an algebra expression that goes with adjacent angles, and they're supplementary. So therefore, we can write angle plus angle equals 180. Now, what do I know about 2 and 8?
They're vertical.
They're vertical angles. What equation do you write for 2 and 8?
2.
Angle 2 equals angle 8, because the measurements of these two angles are equal to each other. They're congruent. So vertical angles are congruent, therefore angle 4 equals, all right, look up here. Angle 4 equals, for vertical angles, angle 6. So I can write the measurement of angle 4 equals the measurement of angle 6 because they are vertical. All right? Now, those occur in the same intersection. Vertical angles and adjacent angles occur in the same intersection. All right, so are there vertical angles down here?
Yes.
Are there vertical angles here?
Yes.
Yes, okay. So we have 2 sets here and 2 sets here. So we have 4 sets of vertical angles in this particular drawing. All right, and each pair is equal to its vertical partner. All right, so now we're going to move into something else. And that is, we're going to move to corresponding. All right, so this particular angle corresponds to this particular angle. This angle corresponds to this angle. Angle 3 corresponds with
Angle 1.
angle 1. And then what am I missing? I guess I'm going to make it home plane. You know home plate was Pentagon?
You're running out of easy to draw shapes.
Okay. All right, so those are corresponding. All right, and if you you are without these particular drawings, you have to ask yourself, where am I located in this intersection? And what is the same intersection or what's the same location in the other? So this is lower left, and that makes this lower left. Now, they are also congruent. So we can say that angle 2, because of corresponding angles, is equal to what? Because of corresponding angles. Angle 2 is equal to angle 4 because of correspondings. But angle 2 is equal to angle 8 because of vertical angles. Now, do you see what's happening? All right.
Because the vertical angles, 6 also equals 2, right?
Well, wait a minute. Let's put it this way. Angle 4 is equal to angle 6 because of vertical angles, right? This is vertical and this is vertical. Now, if I substitute, I'm going to get angle 2 is equal to angle 6. If I take this particular equation and take the 4 and replace it with the 6, I get angle 2 equals angle 6. What is that called? That's alternating interior. So see, you actually get one from the other, but the point that you're going to be tested on is what relationship is the two that I give you. Okay? That's a vocabulary word issue. And a lot of times, whether or not they're equal can be seen because of the picture or the drawing, but the relationships are the thing that is usually tested. All right, so tell me about corresponding angles. What is the definition talking about?
They equal 180.
No, they don't. They're equal to each other. But what makes them corresponding?
They're on the same side, but different.
They're, all right, so they're in different intersections, but they're in the same location. Okay, what makes something vertical? They're across the vertex from each other only, right? And then what makes something alternating is one's on one side of the transversal, one's on the other. And there's alternating interior and alternating exterior. Okay? Now, all right, what about adjacent? Where do you find adjacent angles? Adjacent angles are in the same intersection, and where are the angles located?
On the same
right, they share a line, so they're right next to each other. They're sharing a side. That makes them adjacent. And if you add the two of them up, you have 180. Now, if you have same side interior or same side exterior, they also add up to 180. And that's important when you're looking at parallelograms. So if I give you a parallelogram that's like this, and I tell you that this is 42 degrees, and that this line and this line is parallel, and this line and this line is parallel, then if this is 42 degrees, what do you know about that angle right there? It has to add up to 180, because it's same side. Well, if I add 8, that's 50, and then I add 130, I have 180. Now, these then are also same side interior. And so if this is 138, this has to be 42. And these are same side interior. So that if this is 42, this is 138. And in a parallelogram, two consecutive angles are supplementary. But it comes from two parallel lines cut by transversal. And those are same side interior. Now, what is this value right here that I'm pointing at? What's the measurement of it?
138.
138. Why? Because these two are adjacent angles, right? Or they are alternating interior angles. Right? That's how the vocabulary works. And if you don't buy into the vocabulary, then the questions that they ask, you have no idea what they're looking for. Because they're trying to get you to discuss the vocabulary of chapter 2 with the particular drawings that you're talking about. Okay, now, what happens, what's this value right here?
138.
Why?
Because it is adjacent to 42.
Okay, and 42 are supplementary. What else could you have said?
It's vertical.
It's vertical to
It's vertical to this angle. What else could you have said? It's corresponding to this angle. Right? Now, I got this angle over here that I'm going to call M. Right? Angle M, how does it relate to this angle? The circle.
corresponding.
Corresponding, very good. How does it relate to the box?
Vertical.
Vertical, okay, good. How does it relate to the triangle?
Alternating exterior.
Alternating exterior. There's all your vocabulary words for congruent. That they're all congruent. So I can say M equals 138 or M equals whatever that is. M equals this and M equals that. Now, what about these? M is adjacent to what? Which angles?
The 42 on each side.
No, 1 and 2. It's adjacent to 1 and 2. Okay? What about same side? In this case, I would be same side exterior. M and 3 are same side exterior. So angle M plus angle 3 equals 180 degrees because they're same side exterior. Angle M equals angle 138 because they are same side exterior. I mean alternating exterior. Okay, that's the vocabulary. That's the vocabulary.
And they are corresponding.
Well, okay, we'll talk about corresponding in a second. Okay, let me go back. All right, so I'm going to do 1, 2, 3, and I'm going to call this W. 1, 2, 3, 4, 5, 6, and 7. All right, so I need somebody to tell me some relationship that uses one of those 5 vocabulary words.
The 2 lines are parallel.
All right, that's not in there, but which 2 lines are parallel?
No, I'm just saying they are though.
Yes, yeah, L, okay, L and M. So L is parallel with M, okay.
2 and W are vertical.
2 and W, 2 and W are vertical. Is that right?
Yes.
Is it right? Okay. Then what equation can I write because of that?
Angle 2 equals
Angle W, right? Angle 2 equals angle W, okay? All right, somebody else.
Angle 2 and an angle.
No, go back and we got to relate it to W.
Okay. W and angle 5 are alternating interior.
All right, agree? W and 5 are alternating interior, okay, because they're inside this. All right, and so what equation can you write?
W equals 5.
That's correct. Angle W equals angle 5. Okay, so Casey, go ahead.
3 and W are adjacent.
Okay, 3 and W are adjacent. Okay, so now what can you write for an equation on that one?
Angle 3 plus angle W equals 180.
Very good. Angle 3 plus angle W equals 180.
stole mine.
Okay. We got corresponding, the hardest one.
Wait, which one
We got vertical, adjacent, and alternating interior. So we got corresponding and same side left.
So W and 7 would be corresponding.
All right, W and 7. Corresponding, what do you know about it? It's an equation.
It would be angle W equals angle 7.
Angle W equals angle 7. And that leaves me with the same side. So W and 4 are same side. And angle W plus angle 4 equals 180. Okay? Now, I know that that's helped. I know that's helped because I can tell just by the way that you're saying your parts that it's beginning to make sense. Okay? Now, in this particular, yes, go ahead.
So, let me just double check.
That's right.
So corresponding angles would be W and 7.
Yes.
But W and 4 would be alternating same side.
Well, no, same side interior.
Same side.
Same side interior. Same side and alternating are both interior and exterior. All right. And in some books use alternating and same side as one skill. And some books say alternating interior, alternating exterior, same side interior, same side exterior. All right, so it depends on where you get it, but because if it's alternating and they're equal, there's only one. It has to be alternating interior or it has to be alternating exterior.
So 2 and 6 would be same side exterior.
Correct. Yes. And what do you know about 2 and 6?
They equal.
S word. Yes, S word. They're supplementary.
So-
The sum is 180. So you'd say angle 2 plus angle 6 equals 180 if you need an algebra term for it. All right. What would you do with 1 and 3? What about 1 and 3?
Vertical.
They're vertical.
Vertical. So what algebra do I use?
1 equals 3.
Angle 1 equals angle 3. Right? Okay. Let's see. What about 2 and 5?
2 and 5.
Course. Like,
Corresponding.
yeah.
Yep, they're corresponding. And so what do you know?
Angle 2
Now,
equals
angle 2 equals angle 5. All right. Okay. All right. Now, that is the majority of chapter 2's summary test. That's the majority of it. So, let's see if we can, it's here. All right, so now when we look at this, why is angle 3 equal to angle 1?
because they're corresponding.
They're corresponding. Now you see now you're understanding. See, that's what, if you don't have those vocabulary words, this doesn't make any sense. What about 37B?
They're vertical.
Oh, no, they're adjacent angles.
sorry.
They're adjacent. Okay, so what do you know? The measurement of angle 2 plus measurement of angle 3 equals 180. Okay, good. Now, C says, why is angle 1 plus angle 2 equal to 180?
They're same side interior.
And they're same side interior. Yep, okay. All right, then they give you this, okay, and let's see what they say. If S is parallel to T and L is parallel to M, find X, Y, and Z. Okay, so here's a 70 degrees, here's X. All right, what relationship do they have vocabulary words? What's the relationship?
Same side and
Same side interior, right? Okay, so now what do you know mathematically?
It equals 180.
They equal 180, so X has to be
110.
110, okay? All right, now what do you know about 70 and Z?
It's also going to be 110. because they
But
are
why?
Same side interior.
They're same side interior with different set parallel lines, and so they're 110. Now you should already see a picture in your mind, then what do you know about Y?
It's 70.
It's going to be 70 because you could keep doing that all the way around. Okay, so whenever you have a parallelogram, the opposite angles are congruent. The consecutive angles, means one following the other, are supplementary. But it comes from this parallel lines cut with a transversal. Okay, so now we have this. All right, angle 1 and angle 2 are what kind of angles in this drawing?
Same side.
Same side.
Same side, okay. What is angle 2 and angle 6?
Corresponding.
Corresponding, right? Okay, angle 2 and angle 5 are, now, angle 2 and angle 5 are, no, there's no vocabulary words for those.
Yeah, I mean, yeah.
But angle 2 and angle 3 are supplementary, and then angle 3 and angle 5 are equal, so angle 2 and angle 5 are supplementary. You couldn't answer that because of the way the relationship's set up. But there's no, our vocabulary words aren't there, but the relationships are. All right, this is different. It's a different question. I don't particularly like it. But you see that? The only true answer is supplementary, because the angle 2 in the drawings that we have up there, angle 2 can only be related to this intersection or this intersection. We don't have anything that relates it to that. But we can follow. All right, angle 2 and angle 6 are congruent. Why? Angle 2 and angle 6. They're corresponding. What about angle 6 and angle 5?
Same side interior.
They're same side interior with this one, or same side exterior with this. Or no, yeah, interior. So they're supplementary. All right, if I replace 2 with 6, 5 and 2 are supplementary. And the same thing would be true. What about 3 and 2?
Same side.
Same side, so they're supplementary, and 1 and 2 are supplementary. Therefore, 3 and 1 are congruent. They're equal to each other because they're both supplementary to 2. Yes. Yeah. Okay. Now. Okay, so now here we've got a parallelogram, okay? And we said that the opposite angles are going to be equal and the consecutive angles are supplementary. So number 41 says, if this is 30 degrees, then what do you know about 1, 3, and 4? If this is 30, then what will this angle be?
150.
150, because you're right, good. And if this is 30, how much is this? 150. And if this is 30, then this is 30 also. Okay. So you're going to go 30, 150, 30, 150 around the circle. All right. Now, what would happen if it was 90?
All of them are 80.
All over 90, what do you have?
One.
You have a rectangle. Right. Okay. All right. Now, the tiles are playing. You'd have to know the measurements of these angles to be able to figure that out. But now you do it by hand. All right. So now, whoa! Now we're at this. Okay. All right. A line segment has endpoints. Okay. All right. A polygon has sides, and what is a vertice? What's a vertex? Remember in our vertical angle? Vertex is a point, right? Well, the vertices of the polygon are where the two sides come together. So if you had a square, how many vertices do you have? 4. And if you have a triangle, you have 3. So you have 3 sides and 3 vertices, 4 sides and 4. Okay, so a nonagon has how many sides? An n-gon, sorry. An n-gon has how many sides? N sides. How many vertices will it have?
9.
No, well, no, not a nonagon. This says n-gon. All right, Nonagon, nonagon is a 9-sided figure, so it has 9 vertices. But what will an n-gon have? How many sides and how many vertices? N, whatever that number is. All right, you should know triangle, quadrilateral, pentagon. Pentagon is 5, hex, 6, hex, 6 is 6-sided, and the one that's not 6 is 7, and then 8, nonagon and decagon are the 9 and 10. Regular, all the sides are the same length, and all the angles are the same value. All right, equilateral triangle, you should know that. It's a 3-gon.
Equilateral triangle would be a regular polygon.
It's a regular polygon, yes. Yeah. All right, 2 straight lines are parallel. If they lie in the same plane, don't intersect. All right, parallelogram is quadrilateral, opposite sides are parallel. Rectangle is a parallelogram that also has the angles equal. All right, array is a half line. Starts at a point, goes one direction. How long is it? How long is array? Infinite. Okay, how long is a line? Infinite. Which one's longer?
They're the same.
They're both the same. They're both the same length because they're both infinite length. It just takes the array longer to get there. Okay, what's an obtuse angle? Obtuse, right? Bigger than 90, but less than 180. A cube.
Smaller than 90.
All right, right angle.
90 degrees.
All right, now one that's not in here. What is a straight angle?
It's just a line.
Equals 180. It's flat. Straight angle. All right, and then everything above that is called an oblique. Oblique angle. So, and then this becomes, oh, I'm sorry, I forgot to erase this. All right, so, while we're doing that, okay. Guesstimate the number of degrees in that angle. Somebody guesstimate the number of degrees.
45.
40.
All right, here's something somebody showed me. All right. 45